Okay, continuing with stacks from where we left in the previous session, we just defined stack for us. What was a stack? Anything that uses LIFO processing, last in first out, is what is called as a stack, right? So stack precisely uses last in first out, and that is why we said key it will always represent it like this vertically because it is easier to understand. Now in this particular figure, if you see, if I want to remove this first book, then what I need to do is, sorry, if I need to remove, say, this third book, what I need to do is I need to first remove this one, then I need to remove this one. Only then I'll be able to remove the third book. So whichever is the book which was added at the last will always be removed first, and that is what is a stack. Last in, first out. Then we just spoke about how exactly are we going to implement a stack. Now the first part, what we are required to do is we are required to implement a stack using an array. But just an array is not sufficient for implementing a stack. So along with an array, what I need is I need this pointer called top, which will always refer to the latest value which has been added onto the stack. Now please understand this. If this is an array, all I've done is we always draw an array horizontally. All I've done is I've drawn this array vertically. Needless to say, the starting index of an array is always 0. Next index is 1, 2, 3, and so on. Now, any addition to this array will happen from this end, which is called as push, adding the data at the stack top, and any value which is deleted from the stack will also happen from this end, which is called as pop. Push and pop operations. Top to start with will always be initialized to minus. So over here, now when I want to push another value, say 8, the value of top is 0. So I'll increment the value of top. So top is 0. So now top becomes 1. So always after incrementing, top will give me the index wherever the value needs to be pushed. And that is where I'll go ahead and push this value 8. So just understand this. We start with top as -1, and whenever I want to add a value onto the stack or push a value onto the stack, we'll have to keep incrementing top. Also remember this, please. See, for us, a stack always starts at 0. Now, as an example, suppose if this was the values that we have, suppose these are the values on the stack, then this is where the top is. The reason why it is called as top is because it'll always keep referring to the value at the stack top. Always remember, for us, a stack starts at 0 and ends at top. A stack starts at 0 and ends at top. Now, whatever could be the value of top. Top could be 3, 2, 1. I don't care. For me, the stack starts at index 0 and ends at top. Similarly, when I want to delete a value, all I'll do is I'll have to decrement top. So if top was, say, 1 over here, it will get decremented. It will come back to index 0. Again, if I pop a value, in that case, I'll decrement top. So whenever we are performing a push operation, top needs to be incremented. Whenever we are performing the pop operation, top needs to be decremented. Also, please remember, whenever your stack is -1, whenever top is -1, that means the stack is empty, right? So these were the little operations that we have spoken about with reference to a stack. Now, what we'll do is we will start implementing C programs over here. So let us see how these operations are required to be performed. So let us now get started with the very first program, which is a program to implement the following operations on a stack. So now I'm thinking of implementing a program on a stack. So I'm going to take an array and I'm going to make that array behave like a stack. Precisely on that array, whatever array we will be now creating, I'm going to implement LIFO processing, and then the array will start behaving like a stack. Now there are 4 operations that need to be performed. First is push, second is pop, third is peek and display. Please try and recollect what is peek operation. Peek is similar to pop, but the difference is pop will always return the value from the stack top and then delete that value. What peek does is peek returns the value from the stack top, but it does not delete that particular value. So that is what is the aim over here. So this is what we will try and do. Okay, let me get started with this. So first and foremost, I am just trying to think what is or how am I going to create a stack. So to start with, I'm going to include the regular header file stdio.h, conio.h, and over here, I've used a macro where variable n has been initialized to 100. Now, please remember, if you are working on any of the modern day compilers, if you are working on any of the visual interfaces, you might not need conio, and I'll be writing clr, scr, and get ch. Those three things are not needed. But I have given you programs in such a manner that you run them on any compiler starting right from Turbo C, it is going to work. Now, please understand this. For creating a stack, I'm going to use a structure. Now, one, understand what is the purpose of a structure. When do we use a structure? A structure in C language is always used whenever we are required to work with multiple data types as a single unit. What are we required to do? We are required to work with multiple data types as a single unit. Now, for creating a stack, what I need is, I need an array, right? I'm going to work with an array of type integers, and also I need a variable, say top, which is going to store the indexes. So this combined is going to be a stack. Just an array or just this variable top cannot be a stack. So this combination has to be created, and this combination is going to be a stack. So how do I create this? Now, if I want an ordinary integer value and an array to work as a single data unit, that is why I will have to group them together into a structure. And that is what I have done over here. Structure ST. What is structure ST? I've created a structure which contains this variable top, which is going to act like a stack top. And second is this, I've created an array called stack, which is of the size n. Now, once I've created this structure, if I create a variable of this structure type, how will I do that? Struct st of s. So s is now a variable of this structure type. So if somebody now is asking me, what is the memory for s, or what will the memory for s look like? I'll say s looks like this. So s refers to this collectively. So inside s, I have this array called stack, and I have this variable called top. Now, please understand this. Now, because stack and top are inside the structure variable s, if I want to reach this variable top, I'll write s dot top. Or if I want to reach this array, I'll have to write s dot stack. So please don't get surprised. When we go ahead with our codes, I'll always keep writing s dot top and s dot stack, because the array called stack and the variable called top, I'm going to access them from the structure variable called s. So that is why I'll keep writing s dot whatever. Now over here, because this n was initialized to 100, this array that you see over here, which is going to behave like a stack, has 100 memory locations. So this goes without saying that my program can work for a maximum of 100 values. In languages like C, I don't have the provision. If I create an array like this, I don't have the provision of increasing the memory if need be. So maximum, I can work up to 100 values. Apart from this, for every logical task that we perform, I am going to write a specific function. So I'm going to write 4 functions apart from main in this program. First function, push, which will push the values onto the stack. Pop, which will delete the value from the stack top. Peek, which will return the value from the stack top but not delete it. And then display function, which will then display the stack whenever needed. So now that we've created this structure and we have declared these functions, let us get started with this particular program. So we will now write a program which will implement all the operations, push, pop, peek, and display on a stack. Now this is where we start with the codes. Now this is the code. Now before I actually discuss this code with you, I would just want to demonstrate how exactly is this program going to work. So I'll just go away from this and I'll go to say the Turbo C, from where and include these programs for you. Observe this.
लेक्चर हो रहा है, मार दूंगी, सोने का नहीं गिरा हुआ है.
Okay. Now, please observe this. Now that's the screen for Turbo C. I'll run this program for you. I just want you to understand the execution. Now when I run this program, this is a menu driven code. It will first give you a menu which says 1 is push, 2 is pop, 3 is speak, 4 is display, and it is asking me for the option. Now suppose if I give input as 1, that means I want to perform the push operation. Enter the value to be pushed. Suppose the first value that I'm required to push on the stack is say 6. So enter. So what it has done is it has added the value, but then it's not necessary that I would just want to push a value and stop. I may want to continue. So now it is asking me press Y to continue. The system is asking me whether I want to continue with this. I say yes. I'll just hit Y. When I hit Y, again I get this menu. 1 is push, 2 is pop, 3 is speak, 4 is display. Suppose I want to push one more value. So I'll say 1. It is asking me what is the value to be pushed. Suppose the value given is 9. Enter. Press Y to continue. Yes. Now suppose if I go to 4 just to display this stack, see it has displayed. These are the two values that I had entered, which are 6 and 9. Now it is asking me the bottom line. If you see 6 and 9, now it is asking me press Y to continue. Y. It is again asking me for an option. Now suppose if I say 2, which is say pop, then value popped is 9. 9 was the last value which was added on the stack. I've popped that particular value. Press Y to continue. I'll hit Y. Enter option. See, till I keep giving these values 1, 2, 3, 4, and I keep hitting Y, this will keep continuing. Now suppose if I say 4 again for display, if you see 9 is gone, what I'm left with is just 6. Now over here, press Y to continue. Now suppose if I hit any key other than Y, I'm hitting say G. Now as soon as I hit that, my program terminates. So this is how this program has to execute in a cyclic fashion. So this is a menu driven program. Almost all the codes that we will be writing, we will be writing menu driven codes only. And over here, what we will be doing is we will be running all the programs in a cyclic fashion like this. So that is what is the aim. Now, I don't want you all to look at the entire code, but look at only one statement at a time. Also with this program, what I'm doing is I'm building up the programming idea or building up the programming concept for the rest of the syllabus to come. So please understand this. Now, this is where I'll first write this main function. Now, the role of the main function in these programs would be to regulate the complete program. It will take care of the complete execution of the program. Per se, it is not going to perform any operation on its own or by its own. There are other functions which will do that for me. Now, what I have done is I've declared two variables over here. One is this variable called choice, which has been declared as character. And next is this variable called option, which is declared as an integer. Now, what is the purpose? I'll come to that little later. Also, whenever we create a stack, we need to initialize top to -1. See, please understand this. When I'm creating the stack, when the stack is empty, the top has to be initialized to -1. So this is exactly what I've done right at the beginning. Now just observe this. I've written this do while loop. I want you to understand the role of this do while loop because this is going to appear in a lot of programs that I'll be writing. Now please understand the purpose of this do while loop. See, observe this please. I'll put it here. Okay, now just observe this. When I run this, see this. Oh, sorry. Yes, here. See, what I'm going to do is, I'm going to start like this. I'm going to write do, and then whatever the code, there's going to be a lot of code coming in here. All this code. Then I'll have all this code, and I'll say while the user keeps hitting Y. I'm not writing complete syntax, but just an example. So what is the purpose of this do while loop? In this do while loop, I'll display a menu. 1 is add, 2 is subtract, 3 is multiply, 4 is divide. I'll display, I'll ask for the user. I'll display the menu and ask the user for the option. If the user says option is 1, 2, 3, 4, for executing whatever the option, I'm going to make use of a switch statement. So what this switch statement will do is I'll have all my cases over here. So I'll give you a menu. I'll ask you for the option over here. Whatever option you give me, accordingly, I'll perform push, pop, peek, or display. After that, over here, I'll ask you, do you want to continue? And whatever is the data you give me, if that is Y, this while loop will again go over here, and then the loop will continue executing. So the role of this particular do while loop is that it will make sure that the program keeps executing in a cyclic fashion till the user does not press any key other than Y, this loop will continue. So that is what is the role of, this do while loop. So please understand this. This is the do while loop that we are going to write. So going back to the code, please understand this do while loop. I'm talking of this one. So this do while loop that starts over here and ends over here. So till the user keeps giving the choices Y, this do while loop will continue. Now, whenever this one of these conditions fail, when the while loop terminates, this do while loop terminates, that is when my program will terminate. So that is what is the aim. Now, please observe this. I've started here. Inside this do while loop, first is push, second is pop, third is peek, and fourth is display. So these are the 4 options that the user has given. I've asked the user for this value, enter option. Suppose user has given me option 1. So it will go to this variable option. So what is the role of this variable option in our program? We will always display a menu for the user, and whatever is the option that the user has given me, push, pop, peek, or display, I will capture that particular option in this variable called option. So looking at the value of this variable option, I will know what is the operation that the user wants us to perform, push, pop, peek, or display. Now, because this variable option can take 4 values, I'm going to write 4 cases over here. Switch option. Now understand, this variable option can take these 4 values, 1, 2, 3, or 4. So I have written 4 cases. Case 1, case 2, case 3, case 4. Now suppose in our example, if the value of this option is 1, if the value of this option, variable option is 1, I'll go to case 1. I'll go to case 1. Then what I'll do is I'll call this push function. So from case 1, I'll call push function. We are still to write the code. It will perform the push operation. I'll come back and then break. You know that this break statement will always terminate the loop that contains that break statement. So this break statement will terminate the loop for us. If the value of this variable option was 2, we'll go to case 2. It will call pop function. We will perform pop operation, come back and break. If option was 3, I'll call peek function, perform peek operation, come back and break. If the value of this option was 4, go back, display it, call display function, come back. Now, if the user gives me any option apart from 1, 2, 3, or 4, my default statement executes, which will display invalid option. So that is what is going to happen. Now, assuming, suppose the option given to us was 1. I'll start this again. Observe. Suppose this program has just started. I've initialized top to -1. This menu was displayed to the user. If the user has given option as 1, then I'll come over here, switch option. If the value of this variable option is 1, I'll come to case 1. From case 1, I'll call this push function. Push function will do whatever is needed. We are still to write that code. Then I'll come back and then this break statement. Now, as soon as this break statement executes, see push operation, I was required to perform push operation. I've just completed my push operation. As soon as this push operation is complete, I will come out of this particular loop. Now, when I come out of this particular loop, I'll say press Y to continue. Now, this is where I'll ask the user to press Y if he or she wants to continue. Now, whatever is the character that the user has entered, I will read it using this function called getCh. So getCh function is precisely used for reading a character. Suppose the character given by the user is say Y. Now, please understand, suppose if the user hits Y on the keyboard, it could be uppercase Y or lowercase y. See, for me, it doesn't make a difference. If the user has hit Y, whether it is uppercase or lowercase, I want to continue with the program. So what I'll do is, now this is the bracket for your while statement. Then I'll check while choice is equal to Y. Suppose user had given me lowercase y. So this is lowercase y. Lowercase y is equal to uppercase y is false. This condition is false. But I have put another condition here. Lowercase y is equal to lowercase y is true. Now this is your logical OR operator. Even if one of the conditions is true, like in our case, the second condition was true, this will again go back to do. From over here, it will again display the menu, ask you for the option, and then this will go on. Now, assuming that the user had hit this key called M. So then this is, observe this, M is equal to capital Y would have been false, and M is equal to lowercase y would also have been false. So both my conditions would be false. When both the conditions become false in this while loop, that is where my while loop will terminate, and that is where my program will terminate. So this is how my do while loop is going to work. It will ensure that the program continues working in a cyclic fashion. So now that we've understood the working of main, what we'll now do is we'll take one function at a time, and we'll see how it implements the given operations. So the 4 operations, push, pop, peek, and display. So now I'm going to write functions for each and every one of them. Please observe this. So how is my push function going to work? Now just observe this. First, just look at these diagrams, and then I'll go to the code and we'll try and correlate. See, initially, always remember this variable top will always have the last index which was occupied. So whenever you want to push a value onto the stack, what you will do is you'll increment top. So if top was 0, top will then become 1. And then whatever is the value of top at that index, I will put whatever is the new value that I want. Right? So this is what we plan to do now. Okay, so top is going to store the latest index that we have. If you want to add a value onto the stack, what you need to do is you need to increment top. So if top is 0, then top will become 1. And at that index, I'll put whatever the value that you want. Suppose the next value, so I'll increment top, and whatever is the index, at that index, I'll put the next value. So all you have to keep doing is you have to keep incrementing this stack. But understand this, it is possible that maybe say if the stack has 5 locations, if say top is already pointing to the last index, right? That means the stack is full. Now, if you ask me to push a value beyond this, now the stack is already full. I cannot push this value. Now observe this, I'll just put it like this. Now, assuming that the size of the stack that we had was 5. So n is 5, suppose. So the indexes would be this. So what happens is, first the top is here, I put the first value. Suppose if you ask me to put second value, then top gets incremented here. So I put the next value. Then you ask me to push another value. So what I do is I increment this over here and I push this value over here. You want me to push another value, I increment top, top comes over here, I push it over here. Then I want to push another value. So I'll increment this over here. Top is now over here. And then we will get this value over here. Now, after this, if you want me to push another value onto the stack, it is not possible because array is now full. So that is what is happening over here. So when I want to push a value onto the stack, I need to first ensure that the stack is not full. And only if the stack is not full, I will go ahead and push the values onto the stack. But how do I identify whether the stack is full or not? Understand. If there are 5 values, the last index of the date of the memory on this array is 4. If there are 100 values, the last index would be 99. If there are n values, my last index is always n minus 1. So what I know is if this variable top, the value of this variable top is equal to n minus 1, that means the stack is full. So that is what, or this is how we are going to work, right? Please observe this. So now when I start over here, So if I go with this particular example, if the value of top, whatever is the value of top, that is what we need to check. If the size of the array is n, if s dot top is equal to n minus 1, if this condition is true, that means the stack is full. So I'll say stack overflow. Now, in our case, what we've done is, in our case, we've created a stack of size 100. So the last index would be 99. If the value of top is 99, that means variable top is pointing to index 99. That means the stack is full. Look at this over here. If n is 5, last index is 4. If top refers to 4, that means the stack is full. So if the stack is full, this is the error. But look at this example. Suppose currently stack is 0. 0 is equal to 99 is false. This example I'm talking about. Suppose 0 is equal to 99 is false. That means the stack is not full. So I'll come to this else part. Now coming into this else part, I'll ask you, now value needs to be pushed. I'll ask you, enter the value to be pushed. What is the value that needs to be added to the stack top? So suppose you've told me 14, right? You've told me that 14 is the value which needs to be pushed onto the stack. See, top always refers to the last index which was occupied. So currently top here is 0. Now, if I want to get the next index, top plus plus, this will increment top. So suppose if top was 0, this gets incremented by 1 and it becomes 1. Please remember, I've written s dot top because like what you see in this figure, this array as well as top are inside the structure variable called s. That is why it is s dot top plus plus. So this will increment the value of this variable top, and now the value is 1. So what I need to tell the system is, in this array called stack, at this index will always write in square brackets, at this index called top, you copy whatever is the value in x. So in this array called stack, at this index called top, you copy whatever is the value in x. Now, because both these are structure variables, I'll write s dot stack and s dot top. Now, as per our example, so this becomes s dot stack, and if the value of top is 1, this is index 1, the value of x say was 14, so value 14 gets added to index x. So this is what has happened over here. So what have I done? I've just incremented the value of top. Whatever is the new value of top that I get, I use that as an index, and at index top in this array x, I will push this particular data, and I'll give you a message saying that the value has been added successfully onto the stack. So what is the flow of this particular function? Whenever this push function is called for adding a value onto the stack, I'll first check whether the stack is whether the stack is full. If the stack is full, I give an error. If the stack is not full, read the data into this variable x, increment top pointer. At this new index given by top, you push whatever is the value that you had in x and give a confirmation message saying value added successfully. So this is how my push function will complete the task of pushing the value onto the stack. Let's now go to the next operation that we can perform on a stack, that is pop. Now, try and recollect, what was this pop operation? A pop operation will always return the value from the stack top and then delete that value. Now just observe this. Suppose this is the stack over here. So as of now, top is referring to this index, which is 3. This is the latest value or the last value which was added onto the stack. Now, when I perform this pop operation, I want this value 41 to be removed and I want this value 41 to be deleted. But understand the idea of deletion. For us, we cannot just go out and erase this value 41 as such. No, we can't. All I'll do is I'll decrement top. So now if top instead of this is now decremented to index 2, what did I tell you? For me, stack starts at 0 and ends at top. Now if top is at index 2, then we will always stop our operations at index 2. So this 41 is as good as gone for us. So always remember that whenever you want to delete a value from the stack, all you need to do is decrement top. That's it. But then understand, when you want to delete a value from the stack, it is mandatory that the stack should not be empty. If the stack is already empty, then obviously I cannot pop a value from that stack. So like what we did in push over here as well, what I'm required to do is I'm required to pop the value. Before I pop the value, I'm required to check whether the stack is empty. If the stack is empty, I'll give you an error, else I'll pop the values. Now please look at this. How do I identify whether the stack is empty or not? Whenever the stack is empty, the value of this variable top will always be -1. Always remember this. So what I'll do is, to start with, I'll just check. Right, let's take this. If s dot top is equal to -1. Now look at this example. Suppose if this was the case, this is -1. -1 is equal to -1 is true. If top is -1, that means the stack is empty. This condition is true. I'll come out and say that the stack underflow, or you can say that the stack is empty. But suppose if it was this case, I'll just check. What is the value of top? 3. It is index 3. Always remember, variable top refers to the index and not the value. So this is 3 is equal to -1. 3 is equal to -1 is false. If this is false, that means the stack is not empty. So I'll come over here. So what I need to do is, from this array called stack, from this index called top, I need to fetch the data. So over here, in our case, if say the name of the array is stack, and if I need say an index, so over here the index is say 3, so this will return the value at index 3 in this array called stack. So that is what we've done. So stack, and from this index top. But again, because they are structure variables, I've written s dot this. So what this will do is, from this array called stack, at index top, whatever is the value that is returned. So say suppose if the value was 41, this value has been returned to x. I'll say value popped is x. I'll display the value of x. So this will display the value popped. But now comes the deletion part. S dot top minus. What this will do is, this will decrement top. So top, which was 3, will now become 2, and this value is gone for us. So this is how my pop operation is going to work. Next is peek function. Now, what exactly is this peek function? Peek function is similar to pop, but the only difference is that pop function will return the value and delete that value. So peek function will return the value, but will not delete the value. So over here, see, this was my pop function. See, this is where it was returning the value, and this is where it was deleting the value. If I remove this, if I remove the deletion part from pop, it becomes peek. And that is exactly what I've done over here. Please observe this void peek. If s dot top is equal to -1, what this is, it is also first checking whether the stack is empty. If the stack is empty, error. If the stack is not empty, I'll come over here. I'll return the value from the stack top. It is exactly the same thing. The only statement that I've removed is the decrement of top, which was deletion. So this will return the value and display the value. So pop and peek are pretty much identical. I've just removed the deletion part or the decrement part for the top. And that is how my peek function is going to work. Then we have display. Now, what is this display function? Now, understand, display function is required to display a stack. Please remember this. So suppose this is the stack of say size n is say 5. So this is 0, 1, 2, 3, 4. Now this is stack. Now just observe this. Over here, if I have some value, say 5, 8, 12, 17. So this is top. I told you that for me, stack starts at 0 and ends at top. So all I need to do is I need to display the array starting at 0 going till top, whatever be the value of top. Top could be 1, 2, 3, 4, whatever. For me, I start at 0 and go till top. So over here in this display function, I'll first check if top is -1. If top is -1, I'll say an error that the stack is empty. But if top is not -1, I'll come over here. For I is equal to 0 till I is less than equal to s dot top. Now in our case, s dot top is 4, right? So starting with index 0, going till 4, what will this do? Print stack of I. So what will happen is, first I is 0. So stack 0. What is the value at stack 0? 5. That will get displayed. Then I becomes 1. So stack 1. this will get displayed. Then I becomes 2, so stack 2, so I'll get this value, and so on. So this is how you'll display a stack. This is a normal loop that we generally write while working with an array. This is pretty much displaying an array. So this is how we'll write a program for implement a stack using an array. A quick overview: we first started by creating this structure, and then what we did is we declared all the functions. Main function is just ensuring that this program continues in a cyclic manner. Then we had push function, which will push the value onto the stack, a pop function, which will delete the value from the stack, a peek function, which will return the value from the stack top, but will not delete it, and display function, which will then display the stack for us or display the array for us. So this completes, say, implementation of an array as a stack, or you can say implement a stack using an array.